You ever wonder what's actually happening inside the quote-unquote mind of an AI like ChatGPT? I mean, it really feels like magic, right? Well, today, we're going to pull back the curtain and show you the trick, and we're going to do it by looking at a tiny baby version of a GPT that you can literally run on your own laptop in about a minute.
Okay, so first, take a look at these names. They sound pretty plausible, don't they? I mean, maybe you've even met a Karya or an Ilara. But here's the kicker. These names were completely made up, or hallucinated, by a computer program.
And yeah, that brings us to the really big question of this whole explainer. How on earth can a program, and we're talking a simple set of instructions, just 200 lines long, appear to be creative? What does it even mean for it to learn? All right, let's dive in and find out.
To crack this mystery, we're going to look at this absolutely brilliant little project called microgpt. It was created by the AI researcher Andrej Karpathy. It's a fully functional GPT model, but he's boiled it down to its absolute bare-bones essentials.
I mean, you can just feel the passion in this quote, right? Karpathy's goal wasn't to build another giant, massive AI. No, it was to create the perfect learning tool, a crystal-clear window so we can all peer right into the algorithmic heart of these incredibly complex systems.
All right, so where do we even start with this? Well, the very first hurdle we have to get over is that computers, they don't speak English. They don't understand letters. They only understand numbers. That's it. So the first big challenge is, how do you teach a machine to read something as simple as the name Emma?
The answer is something called a tokenizer, and you can totally think of it like a secret decoder ring. It's actually super simple. It just takes every unique character in its data, in this case, just the letters A through Z, and it assigns each one a unique number. We call that number a token.
So just like that, the name Emma gets turned into a simple list of integers. The E becomes a 5, M is a 13, and so on. Oh, and it also adds a special token at the beginning and the end, kind of like punctuation, to signal, hey, the name starts here and it ends here. And boom, now the computer finally has something it can actually work with, a sequence of numbers.
Okay, so the model has this huge list of names, all turned into streams of numbers. Its one job, its only job, is to become an expert at predicting the next number in any given sequence. But how does a machine actually learn to do that?
Well, it learns by measuring its own mistakes. And there's a name for this measurement. It's called loss. A really easy way to think about it is as a surprise score. So if the model sees EM and predicts the next letter will be Z, but the right answer is A, whoa, the model is super surprised. That means it gets a high loss score. The whole goal of training is just to make the model less and less surprised over time, to get that loss score as close to 0 as possible.
And this whole learning thing happens in a loop. You can see it broken down right here. First, the model predicts. Then, it measures its surprise, which is the loss. And then, and this is the absolute key part, it figures out exactly which of its internal numbers to adjust and in which direction to make a slightly better guess next time. Then, it just does it again and again, thousands of times, getting a tiny, tiny bit smarter with every single pass.
Now, that process of finding the direction, it relies on a calculus concept called the chain rule. And I know, the word calculus can sound complicated, but the idea is actually super intuitive. It's just about multiplying rates of change, kind of like this quote explains. This is literally how the model traces a mistake all the way back through its network to know which specific little knob to turn to fix it.
So we know the model adjusts its internal knobs to get better. But what are those knobs really? Let's peel back another layer and look at the actual architecture of this tiny AI brain.
In total, microgpt has just 4,192 of these adjustable numbers, or parameters. And these numbers, they are everything. They start out as just a jumble of random values, but through that training loop we just saw, they slowly get organized to hold all of the statistical patterns of the names in the training data.
And those thousands of parameters are organized to do two fundamental jobs. First, there's attention. That's the communication part. It lets the model look back at the previous letters to get context. Then there's the MLP, which is the computation part. This is where the model thinks, and I'm definitely using air quotes there, about the context it just gathered before making its next prediction. And honestly, the entire transformer architecture is just these two blocks, communication and computation, stacked over and over.
So we have this tiny little model that can generate names. How does that stack up against a behemoth like GPT-4, something that can write essays and code? Well, the answer is all about scale. Just look at these numbers. It's wild.
MicroGPT has a little over 4,000 parameters. GPT-4 has billions, with a B. Our model trains on 32,000 names in about 1 minute. GPT-4 trains on trillions of words from the internet for months, using thousands of powerful computers. And the craziest part? The core algorithm is exactly the same. The difference in resources is just astronomical.
So now that we've seen inside the machine and we kind of get the process, we can finally answer that big question from the beginning. Is this little program actually thinking or understanding?
The simple, mechanical answer is no. As Karpathy says, there is no magic. The model is just an incredibly complex mathematical function. At the end of the day, it's a pattern-matching engine that has gotten extremely good at calculating the probability of what token should come next based on all the tokens it has seen before.
And this brings us right back to those names from the beginning. The model hallucinated a name like Haria not because it's creative, but because that sequence of letters is statistically plausible based on the 32,000 real names it learned from. And this, right here, is the exact same phenomenon that causes a huge model like ChatGPT to confidently state a false fact. It has no concept of truth, only statistical likelihood.
And that leaves us with a fascinating final thought. We've just seen that a simple, mechanical process of statistical pattern matching can produce results that feel new and creative. So, if no understanding or consciousness is required to do this, what does that really tell us about the nature of our own creativity? It's a question we're thinking about.